Hello everyone, I'm Skylar Hart with Team 2. I wanted to reintroduce our project and give you an overview of what we will be covering in our progress report. We will go over what has been completed and then transition to the work that is remaining. Our project is to detect and characterize RF signals using software-defined radio. We are doing this by developing an algorithm to evaluate the in-phase and quadrature signal components of an RF signal. Our mentor is Todd Simon from General Dynamics, and our team members are listed on the screen. Now here is Hunter to describe part of our algorithm.
Hello everyone, my name is Hunter Riley. I'm going to talk to you a little bit today about GRScan and what we've done with it since last semester. So, as we've mentioned before, GRScan is a C++ application that uses the GNU Radio API to scan a desired frequency range and find signals within that based on finding peaks and if they're above a certain threshold. A feature that we've added is that as it finds these frequencies, it will then catalog them in a CSV file and record a snippet of them, of their IQ data, that can be used for later analysis. And that way we can catalog each one and say, okay, this one has been identified, this one has not been identified, and so on and so forth. Another feature that we're still working on is the ability to use a binary file as the signal source. So instead of listening for radio stations, we would use this file of a known recording, pass it through GRScan, and we can verify that our detection methods are working as we want. And that wraps it.
Hi, my name is Guillermo, and I want to talk to you a little bit about what I've been working on in this project. So the main role that I've been playing on this project is writing this script, the MATLAB script that will do the frequency analysis. More specifically, what I've been working on is determining whether a signal is FM or not, frequency modulated or not. So after the signal is captured with GRScan, if a positive signal ID was made, signal detection was made, then the script will take this data and then do some frequency analysis on it. So for example, I will take the signal, take a window of 1,000 samples FFT, and I will store the maximum value of it, and then I will do that consecutively for X amount of times, and then I will see if there's a frequency variation on the maximum value. So if the variance of the max of every FFT is more than a specific threshold, then I know that my my signal has some frequency modulation characteristic on it. So that's mainly what I've been working on when it comes down to the signal analysis. We are still working on the AM modulated signals. So if I have an AM signal, what the plan is to take the signal. If the frequency is not varying, then I'm going to look at the amplitude of the signal on the FFT. If it's varying a specific amount, then I'm going to say that my signal has some amplitude modulated characteristics on it. And on top of that, we're also going to work on a couple more modulation types for determination. What do we have left to work on? Something else that I've been working on is on the test protocol. So I also have some 50 ohm loads that we've been plugging in place of the antenna to make sure that we're not detecting anything that we shouldn't be detecting. I've also got an FM source, so I can directly connect an FM source to my HackRF and make sure that we are ignoring all the other signals. So that's kind of like the test parameter that we're going to use to baseline our system, make sure that we're not detecting anything that shouldn't be there. The other thing that we're still got to work on is the test protocol. What are we going to call our project a success? If 80% of the signals that are FM modulated get properly identified, then that's just to throw a number, then we will call it good. I think that's about it for now. I'm running out of time. Thank you.
Hello, Arizona State University. My name is Marco Martinez, and I am here today to talk about our software-defined radio capstone project. First of all, one of the best ways to keep track of our progress has been to simply document our test runs. Secondly, we made a how-to guide for use in development to stay synchronized with each other. This is important because it keeps everybody on track and shows what we have in our hands.